HTTP is the most commonly used protocol for this kind of communications, right? So what are the methods? We have three here. One is SOAP, REST, and XML RPC. Okay. Let's move on. Now we have something called machine-to-machine communications, right? This is a representation of state transfer, REST. Okay. It supports data formats such as HTML, XML, JavaScript object notation, which is JSON, right? And it inherits HTTP operations such as get, post, put, and delete, right? When we are talking about machine-to-machine communications, what are we looking at now? Data, right? What are the most common applications of machine-to-machine communications? Anyone taking what we call IoT? Right? So IoT, you always use sensors, right? And then sensors are actually sending back data to the servers, right? Those are machine-to-machine communications. Okay. So in machine-to-machine communications, we also have simple object access protocols. Okay, but this one, the format that we support is XML, right? Then you can actually work with the application layer, right, such as HTTP, SFTP, TCP, and UDP. So what are the data format that we have? We have XML, JSON. This is how they look like, right? I think most of you are already quite familiar with JSON here. Okay, so this is how your JSON data format looks like. So this is SOAP data format. Okay, so we have Android JSON parser. Okay, so in here, most of our Google's APIs are available as JSON REST services. Okay, JSON is the fastest and easiest way compared to XML, right? So that's why a lot of things are in JSON. And Android uses a JSON object to read JSON streams. So, right. So over here, okay, how does our sample data look like just now? Okay, in here also we have one, right? And this is how we actually created our JSON object over here. You can take a look. If you need this in your assignment, you can just have a glance through, right? Now, background operations. So last week we touched something like the main thread and also the background threads. So this is what it is. UI and network operations should be implemented on the different threads. Okay, Android will actually throw a network on main thread exceptions if you perform any network operations on your UI thread, which is the main threads. Okay, so like we touched on last week, we have main UI and then background, right? Just a refresh from last week. What are the things that we can actually, what are the components, okay, that we can actually use to have long-running operations? You want to make it run in the background thread instead of in the main threads. Start with C. Call routines, right? But today we're going to look at a different one. So main versus background threads, okay, this is where all your user interface happens. That's why we cannot jam up your main threads. Okay, if you have any long-running operations in your main threads here, your Android will always throw you exceptions. Okay, it will render saying that your device is unresponsive. So that's why any heavy operations have to bring them to background threads. That include the network operations, because the network one will be the one that is very heavy and will take up a lot of time. Okay, so here are the example of what are the long-running operations like decode bitmap, this IO, and IO. Okay, so let's take a look at here. we have background solutions. Is it network I/O? If yes, we go to download manager. Okay. If it is not a network I/O, then what do we do? We check on, is it now or never? Okay. Are we going to use it now or no? If yes, then we go for foreground services. Again, if it is no, depends on system conditions, right? What are we depending on? The task that we want to run. Okay, then we will, if it is yes, then we pass to work manager. Okay, if we wanted to run at a specific time, we pass to alarm manager. But in the very end, right, it always goes to the work manager. This is the least one. Okay. Right, so here, this is what I mentioned just now. When we have the download manager, we want to perform long-running HTTP downloads. That's what we use for when it comes to download manager. Then program services, user initiate work that needs to run immediately. That's why we have the now or never. Okay, user want it to run immediately and must execute to completions. Right, while alarm manager is to do the job at the time that you specify. Right, and then we sorry, that one is alarm manager. Then we have the last one, work manager here, runs deferrable background works when the works conditions like network availabilities and powers are satisfied. Okay, any questions so far? Over here? Oh, okay. Okay, continue on, we have network operations. So transferring data via network. Okay, in Kotlin itself, we can actually use our work manager, right? And what we also call core routines, which I have covered last week. Okay, if you use sync adapters for transfer of data regularly and efficiently, okay, you can actually use them. But remember, this is not instantaneously. Right, if you use sync adapters. Now, connecting to the network, you will always need to ask for permissions. Where do we put these permissions? Manifest, XML, always remember. Okay, there's two that we need to ask for. One is the permission for internet, and then permission for access network state. These two. Right? So network communications best practice, there's two, right? You have to minimize the amount of sensitive data that you want to transmit over the network, right? And then send all network traffic over the secure socket layer, SSL. So if you started to actually implement apps onto the server, you will find that you will have a lot of problems with SSL. Okay, there's a lot of things that you need to configure when it comes to SSL. You need to have the certificate, and if your certificate has to renew every time, you have to consider all this. Okay, if you do not buy a certain certificate, only use generated by your server, your certificate has to be changed every 3 months. Every 3 months. So it means that every 3 months you have to update your apps. So it will be very troublesome. Alright, so if your company is doing it, they might opt to go for longer durations, which is like they are buying as SSL for 1 year durations. Then you don't have to update the apps. Okay. Okay, then now we are going on to the next topic here, determining a status of the internet connections. How do we actually determine whether we are connected to the internet or not? Right, we use the connectivity manager here to ask whether there's an active network. Right, if there is, then what we want to do with it. Okay, this code synapse here, right, show you how we can actually use connectivity manager. Right, always you are going to create as object holder. Okay, and then we pass in the context to get the connectivity service as a connectivity manager. Okay, we are passing this whole thing as a connectivity manager, right? Then we say, is there an active network? Right, extending from network info. And then from here, we say cm.activeNetworksInfo. Where is it? Right? So this is conditions. Is it connected in our active network? Yes or no? Right? Then we determine the type of internet connections that we have over here. Okay. So this is how some of your apps sometimes ask you, especially the streaming apps. Okay, they're asking you, where if you are not connected to the Wi-Fi, do you want to proceed on with the videos? Means that you are using your own 5G data or data. Okay. So network connections, right? Network operations can involve unpredictable delays. Okay, why is this so? The first point here. It depends on what? It depends on what type of coverage that we have, right? If you are using Wi-Fi, yes, and even sometimes Wi-Fi you also have delays because of the network speed, right? Perform network operations on a separate thread from the UI, okay, so that we do not have these delays jam up your threads. Okay, use the sync task to perform network operations. So what is a sync task? Okay, it's very similar to coroutines. It performs background operations and publish results on the UI threads. Right? So this is UI threads on pre-execute. We go in for a sync task. We do it on the background, and then once it's done, you go back to your UI threads here. Right? Very similar to coroutines. Okay. So over here, if let's say in the UI thread itself, okay, we have the network fragments. We want to ask for a task to be completed. We pass it down into a sync task. When it's done, then we call back to our network fragments. Okay. So a sync task itself, it must be a private subclass, right? What we need to do, we override at least one of the methods, which is the do in the background. Then what are the things I want to pass in? Okay, and also on post execute, what is the results that we want to receive from this task? Okay, are these suitable for short operations? Please bear in mind for a sync task. Okay, so moving on. How are we going to convert input streams to a string? Okay, in input string itself is actually a readable source of bytes. Okay, we can actually decode or convert them into a target data type. So this is how we convert it. We have our input stream here. Okay, we put it as a null, but because we have a null safety check here, right? Then we have our bitmap passing it into a discode stream, right? And then we download image file and display it. Okay, explain the relationship of the three main components of a mobile solutions. Let's do this out. So same thing, go to your Google Jamboard to answer these questions.
Maybe you can use different colors, huh?
Okay, so let's take a look at this one now. So the question number 1 here, explain the relationships of the 3 main components of a mobile solutions, mobile app, API and backend. So mobile app will provide the UI, the API is used by the mobile app to communicate with the backend. The backend handles all the heavy logics. Okay, good. Right. So how about others? Okay. The mobile app provides the user interface, the API facilitates communication between the app and the backend, and the backend handles the what here?
So got the answer beside.
Where?
So got the beside one. This.
Oh, this one here. Handles the underlying logics, data management and processing. Okay, right. So how about others? The others? So mobile solutions encompass both mobile apps and APIs. Mobile apps are software application with functionality. This part here facilitate communications. This one is correct. Okay. Mobile apps are software applications with functionality. So here you're actually mentioning as UI, right? Okay. How about your backend? You don't mention backend over here. Okay. Doesn't matter. Let's move on to question number 2. Why a mobile app should not implement network-related tasks on the UI threads? So it is because network operation is a heavy and long-running task. Running network operations at the main threads cause exceptions being thrown. Okay, correct? Network operations often involve waiting for data to be fetched from remote servers. If these operations are performed on the UI threads, they can block the threads. Yes, good, correct. Okay. Performing network-related tasks on the UI threads can lead to unresponsive and sluggish user interface. Correct. Okay, good. Explain the use of the sync task in the network operations. The sync task will help the performing network operations and the backend and send the result back to UI. Yes. Over here, this one. See, we flash a little bit. So a sync task is a class in Android that helps developer to manage asynchronous operations on separate threads, particularly for short-lived tasks like network operations. Right. A sync task class is used to do background operations that will update the perform operation networks and publish result to. Okay. Right. Good one, everyone. Let's continue on. Okay. So we can actually use volley, right? If we want to transmit data. So volley is a HTTP library. It's used to populate data to the UI, okay, which is the main thread, right? But it is not suitable for large download or streaming operations. What are the things that data type that we support is strings, image, and JSONs for volley. So what is the benefits of volley here? It automatically schedules for network requests. It can handle multiple concurrent network connections. It will be able to support your request for prioritizations. Okay, and also it supports for cancellations of requests. So that's why we can actually, this is the benefit of using volley itself. So if you want to use volley, you will always need to have this dependency included, right? Over here. This is where the volley coming from. Okay. Right. So there are 3 different requests, okay, that you can that volley can support. 1, string request, JSON object request, and JSON array request. So what are they? So when it comes to string request, means that we are retrieving raw strings in response. Okay. And if for JSON objects request, of course we are looking at JSON object response, and the same goes for the array, JSON array response, right? So this is how we how the code looks like if we want to handle string requests. The main part here will be this one. Okay, request a string response on the provided URL. So we have here our objects here, string request. Okay, then we pass in our get and then URL. Okay, URL is from here. Where is it from? Okay, and then we pass the response to our text view.text, text view here. Okay, so whatever we get from our strings, we're gonna pass it to our text view. You can try this at home, right? This is a very simple one. You can actually try and fetch this. Right. So you can use this as well, right, for your URL. Now, when you want to cancel requests, okay, means that you do not want the request to be done by the body. Okay, this is how we do. So oftentimes, right, if you are doing live data this week, okay, you can also look at how to use live data to react upon any events that happens to your data. If there's changes to your data, you want to cancel the request, okay, you can link live data to this cancel request here, right? Okay, now move on. A basic request queue needs a web network plus a cache, alright? Use the basic network and this base cache to instantiate our cache here. So this is two simple way for request queue. Alright, okay, look at these two codes here later on. Now, if your apps itself need to constantly connect to the network, right? What you can do is you set up a singleton pattern. Okay, singleton pattern here is actually quite common, especially when it comes to network usage. Implementing a singleton class that encapsulates request queue and also body functions. So what we have seen just now, the code synapse, okay, you can use the single pattern, okay, so that you can use it throughout the life cycles of your applications. So I won't go through this one, right? If you have time in the lab, then I shall show you this code. Okay, moving on. Then we have JSON request here. Okay, how are we going to do JSON request? We're gonna create, of course, we always have our URL, right? And then we have our objects again. And this object is gonna come from JSON object request. Okay, so this one again, you have to input, import. If not, you won't be able to do it. Right? So respond, getting a response again from here, and this one, this is actually from your singleton. If you implement this singleton class here, you can use it when it comes to performing the what we call JSON request. Right? Access the request queue through your singleton class from here. Right? Okay, moving on. So this one, MQTT, right, is good to know for your apps itself, right? Message queuing telemetry transport. Where do we always see this? MQTT. Huh? What? IoT? Right? When there's a machine-to-machine connectivity or communications that we need, MQTT can be used. Right, so this is how it looks like. Internet of Things, okay, whereby we will subscribe your sensors to pass it to MQTT broker, and then from MQTT broker we can actually publish it to your devices. Right? Move on. We're not gonna touch too much on this one. This one, no need. Let's move on to mobile server options. This one will be the last part here. Okay. So mobile app servers as the UI or front end. Okay. Backend provides database, scripting APIs, and architectures for the apps. Okay. And also it allows you to connect to DB to your apps. So there are three main core functions. Okay. One is application server, web servers, and so the database. So what are the backend technologies that people often use? Right? You can see Ruby on Rails, Express here, Django. Right? Some of you are using doing your database, your FIP, you're gonna use Django. Okay. Then we have PHP model view controller frameworks, and of course we have Firebase. A lot of you is going to use Firebase, I think, for your assignment. Okay, doesn't matter if you are familiar with it. Go on ahead. Okay. So, what is the options when it comes to server? Okay, three. We can do DIY, means that you're gonna build your own server, right? Whereby you will have your own APIs and database. Or we can actually use subscribe backend as a service. Okay, so these are like the AWS, Huawei, Google Clouds. Those are all subscribe. So having said, if you subscribe, okay, you get access to a lot of functionality, right? Such as AI, quality control, security, etc. And the last one we have mix and bang. You do it's a combination of DIY and subscribe, whereby you will have your own server, but a lot of services that we can actually capture from the what we call cloud services platform. So let's go into a deeper one. So do it yourself. Create your own server. What are the advantages that you have here? One, you have the complete control of everything. Okay, from hardware, software, network, and services, it's all in your control. Okay, but you need a lot of time to monitor and maintain it. Okay. So the disadvantages itself are you will have heavy customizations, complexity increase, security vulnerabilities, insufficient performance, defective reliability, poor functionality, and technical debt. So what are these? When we say heavy customizations, because when you have your own server, you need to set it up. Okay, means that you're gonna have your own server room, and this server itself, when it comes, it has nothing. You have to set it up by your own. So you have to customize everything according to your needs. Okay, very complex. You will need a database, a network engineers, okay, a database engineers, right, to actually help you to establish this server. Insufficient performance. So why is this here? So when it comes to the server itself, if you want to do AI trainings on the server, you will need to set it up on your own. Okay? So that's why we say the performance is lacking, and also depends on what kind of servers that you are using, the hardware itself. Okay? Defective reliability. So oftentimes when we have, because you are working on a one server, so if that server is down, that means that it will disrupt your apps itself. If you are doing it on the apps, okay, your system will be disrupted. Okay, then you will have downtime. When it comes to business, when there's a downtime, it will cost a lot of money. Right? Poor functionalities and technical depths are. This is technical depths in terms of what we call. Just like I mentioned, you will need a specialized person to actually handle the server. Okay. The second one, servers options, is for subscribe. So this is actually quite popular, whereby you have cloud. Okay, this is a delivery on for on-demand computing resources. So when we talk about on-demand here, when you subscribe, for instance, we subscribe for Microsoft services, right? Azure. Okay, Azure will only charge according to what we use. Okay, so we do not need to have upfront investment to do our own server. Okay, it's not going to be cheap if you do your own server, right? And of course, you'll get access to different kind of services provided by that platform. Okay, so then here we will also talk about container. So container actually offers a logical packaging mechanism by which your application can be abstracted from the environment where they actually run. Okay. Then we also have virtualizations, process of running a virtual instance of a computer system in a layer abstract. Okay. So instead of having your own server, you will have a virtual machine. Alright. And then backend as a service, this is a delivery model of set of tools that help you to collaborate between organizations' software development team. Right? So let's take a look at this one. Container is quite new in terms of
IT delivers thousands of applications to meet the needs of your business. Many have different requirements. They also use different languages, databases, and tools. To deploy, configure, manage, and maintain this complexity takes people, expertise, and the right systems, infrastructure, and architecture. This translates to time and money. Today, there's a better way to package applications and their necessary components with Linux containers. Containers help organizations become more consistent and agile. They abstract the underlying host operating system. As a result, applications can be packaged with all of their dependencies, so your developers can choose the environments and tools that best suit their projects, and operations teams can deliver applications anywhere in a consistent way. It's easy to see the benefits when you deploy your first container-based app. But what happens when you're developing, deploying, and managing thousands of containers each day? Securely delivering and maintaining container-based applications at scale can be complicated. Red Hat can help. Find out how your organization can use containers without being overcome by complexity.
okay, so that's some brief things about container. So moving on now. We're almost there.
Hello everyone. In this video, we're going to talk about
Okay, so let's take a look at the advantages of subscribe. So one, it is cost efficiency because you only charge per use, right? Scalability means that if let's say our user that we have currently is only like 1,000 per day. Okay, do we need a servers that run that have the capacity to run up to 10,000 user per day? No, right? But if you are doing it on your own DIY, you have no choice but to actually do it first. Okay, if not, when it comes to that amount of people, then you need to buy another set of servers, which is not viable. Okay, that one is for DIY. But when it comes to subscribe, you can scale it whenever you want. Right? Say you at the initial state you have 1,000 users. Okay, but it dropped to 500. You can scale it. Okay, scale it down, scale it up. Depends on your usage, and also it depends on time. Okay, sometimes there are time frame whereby there's a lot of users coming in. You can also scale it according to time. Okay, certain time you open up more resources. Certain time you just scale it down. Right? The speed. Okay, you don't have to worry about the speed. The integrations. You just need to subscribe it, link it up, and of course when it comes to audit and compliances, you don't have to worry because all this has been taken care of, right? But the disadvantages is pay for use and the security itself. Okay, anyone know CoinGecko? No. One of the well-known website for cryptocurrencies that were actually built by Malaysians. They're actually using Azure. Okay? Okay, they are using Azure. The last I heard of a year back, they have most of their cost is actually putting on the Azure itself. Okay, as they scale up, a lot of people using their websites, their cost for that service itself increased a lot. Okay, almost reaching for 40% of their operation cost. Okay, that's a lot. Comparing up, that's a lot. Okay, then of course it comes to security, but here it depends on what kind of what kind of server options that you're subscribing to, right? Some they already have quite a good security implemented, but the data itself is not on your hand because everything is on their side there, right? So let's move on. So what are the services that they can actually do here? We have storage, post notifications, analytic users, social integrations, user administrations, and so on. What I want you to see is this one. Okay. So we have Firebase, Azure, right? Huawei Clouds, Amazon's, Azure. The most common one is Azure, right? And Huawei Cloud. Okay. Alright, this one we don't have to go through the details.
Hi, my name is Arman Hazarkani, and this is an introduction to Google Cloud. This video is intended for use by anyone interested in preparing for their future careers. In the next few minutes, we're going to discuss what Google Cloud is and what some student developers have been able to create with it. Ready? We're going to start by going back in time. Let's pretend for a moment that we're in the time before cloud computing, and we want to start a company to create a social networking site. You'd start by buying a server, lugging it all the way home from the store, and spending hours preparing it with all the correct hardware and software so it can run your company's web app. Fast forward a few months and things are looking up for your company's site. The users are flooding in. As your organization's user base grows, you have to buy and install more and more servers. This is called scaling. Eventually, you're doing so well that the company opens up a data center. Next thing you know, you're international and spending billions of dollars opening data centers all around the world. Sounds like a lot of work, right? Here's the good news. You don't have to do any of that. Luckily, some companies have spent years building some of the world's most advanced networks of data centers. Cloud computing is when these companies allow developers to store data and run code on their computing infrastructure. Google is one of these companies. Google has data centers all around the world that have allowed it to scale to billions of users. These data centers house the computing infrastructure that powers the Google products you may be familiar with, such as Search, Gmail, and Google Photos. Google Cloud gives you the access to the same technology and infrastructure that powers Google. This means that Google Cloud has over 100 products and tools in categories like compute, storage, and machine learning and artificial intelligence that seamlessly integrate together, all a click away. One category is compute. These products help you deploy code to the cloud. For example, we may use a compute product like App Engine to deploy a social networking site. Another category is storage and databases. These products help us store data, retrieve, and query data in the cloud. For example, we may want to store data for our dog walking app, the dog's names and locations in a cloud Firestore database. We also have machine learning and artificial intelligence. These products allow us to leverage Google's AI technologies for our own applications. We can build and deploy our machine learning models to AI platform, or take advantage of one of the easy-to-use, pre-trained machine learning APIs like Vision or natural language. So, what is Google Cloud? In a sentence, Google Cloud lets developers build and host applications and websites, store data, and analyze data, all on Google's scalable and reliable computing infrastructure. Now, let's see what some student developers have done with Google Cloud. A team of student developers called Guardian worked together to help Alzheimer's patients with a GPS-enabled smartwatch. The Guardian team leveraged a lot of the Firebase platform for their application. Firebase is Google Cloud's comprehensive mobile development platform. The team used Firebase authentication to easily verify app users, Firebase Cloud messaging to send push notifications to different platforms, and Cloud Functions for Firebase to execute backend code without having to manage a server. They also used Cloud Firestore, a Google Cloud database to store and sync user data. A team of student developers created a service called Nagish to help people who are deaf or hard of hearing talk on the phone. They leveraged Google Cloud's text-to-speech and speech-to-text APIs to convert back and forth between voice and text. And that's it. Let's review. We started by talking about what Google Cloud is, a platform that lets developers build and host applications and websites, store data, and analyze data, all on Google's scalable and reliable computing infrastructure. Then, we discussed some of the incredible projects that student developers were able to build with these tools when working to learn skills for their future careers. My name is Arman Hezarkhani, and I can't wait to see what you build with Google Cloud.
Okay, so this is one of it, which is Google Clouds. You can actually go and try for the Google Clouds and register yourself. I think for students itself, free, right? Okay, go for it. Then we have Amazon's. Okay. Why you like AWS so much? Alright, 2 minutes. Then take a look at this one.
AWS is the world's most comprehensive and broadly adopted cloud platform. Millions of customers trust AWS to power their infrastructure and applications. Organizations of every type and size are using AWS to lower costs, become more agile, and innovate faster. AWS provides on-demand delivery of technology services via the internet with pay-as-you-go pricing. You can use these services to build and run virtually any type of application without upfront costs or ongoing commitments. You only pay for what you use. AWS gives you more services and more features within those services than any other cloud provider. This makes it faster, easier, and more cost-effective to move your existing applications to the cloud and to build anything you can imagine. From infrastructure technologies like compute, storage, and databases, to emerging technologies such as machine learning and artificial intelligence, data lakes and analytics, and Internet of Things. Building on AWS means you can choose the right tool for the job. For example, AWS offers the widest variety of databases that are purpose-built for different types of applications. With AWS, you can leverage the latest technologies to experiment and innovate more quickly. We are continually accelerating our pace of innovation to invent entirely new technologies you can use to transform your business. Like pioneering the serverless computing space with the launch of AWS Lambda, which lets developers run their code without provisioning or managing servers. And AWS built Amazon SageMaker, a fully managed machine learning service that empowers everyday developers and scientists to use machine learning without any previous experience. We are constantly expanding our global network of AWS regions, so you can access AWS services to build and run your applications from anywhere in the world. Each of these regions has multiple availability zones that are physically separated from each other and connected by low latency, high throughput, and highly redundant networking. This makes it easy to design and operate applications that are scalable, fault tolerant, and highly available. Our infrastructure is built to satisfy the security standards of the most risk-sensitive organizations. You also have access to the AWS Partner Network, which has thousands of systems integrators who specialize in AWS services, and tens of thousands of independent software vendors who adapt their technology to work on AWS. With the largest community of customers across every industry, AWS has unmatched experience and operational expertise you can depend upon for your most important applications in every imaginable use case.
Okay. Right, so then we have Azure here, and we have Apple Cloud Kate, and Alibaba Clouds. Okay. So questions here. Compare subscription-based and traditional DIY server solutions for the mobile app. Yes, traditional one is more expensive, somehow. And then? Right? If such question coming up, you can actually do a table to compare it up. Right. So this is how I do this. So H&H in Malaysia's largest car parts suppliers. The company hires more than 500 salespersons to sell its product. Currently, the company operates the web-based inventory systems. H&H teams need a mobile solution to solve two problems. Search functions on the web-based system are slow, resulting in a poor user experience. Inefficient territory management. The territory is measured by the number of salespersons against the active customer. Propose new features to include push notifications and chatbots suggest a way to deploy these features in the most secure and cost-effective manner. This one, if you want to answer it, okay, let's try it. Doesn't matter. Right, anyone who wants to try and answer, you can put it in. So this one will be your last question to answer. Then once you are done, you can actually go. Okay, it don't have to be in your tutorial group. You can answer it individually as well. Right? Give you a few minutes to look at this one. Okay, 5 minutes up. Let me take a look at this. So anyone trying to answer already? Yes? This one a little bit trickier, okay, because the question is quite open-ended. So there's two problems that we want to tackle. One is the search functions, another one is the inefficient territory management. Okay, so let's try to scale it within the scope of this chapter itself. So search function on the web page was slow. So how can we actually increase the search if we have it on our mobile apps? Okay, for the first problem itself, let's talk about what kind of server options that you can actually choose. We have three, right? One is DIY, subscribe, and then one is DIY plus subscribe. So which one do you think is more suitable when it comes to this one? We have about 500 salesperson. What do you think? Here they want more speed, right? So they want more speed. Do you actually build DIY? No, right? Subscribe. Okay, because subscribe can actually provide more speeds to access their database, right? And they have other services that they can actually use on. How about the inefficient territory management? Okay, this one we can open it up. We can open it a bit and see what idea you can actually come up with. Anyone? So inefficient territory management, how do we tackle that? Not really, not really. This one is more towards functionality now. Okay, you have to put yourself in sort of like a project manager shoe. Okay, when you have requirements such as this one, you have to figure out what are the things that you can do for them. Okay, so here it says propose new features include push notifications and chatbot, suggest a way to deploy these features in the most secure and cost-effective manner. So just now we already mentioned about subscriptions, right? Okay, so we can actually use subscription service to help us to build this app whereby we have maybe you want to put in AIs to calculate to distribute your salespersons, okay, according to the number of clients. Okay, but all this you have to do it on a subscription platform because it is much more cheaper and more efficient for us to use that. Okay, any questions for today's class? Oh, by the way, I forgot to show you this. You won't ask for the code until the end. Right, so that's all for today. Thank you for coming. Remember, next week, bring your paper, right, to answer your questions. You will have quite a number of questions. Okay, so you might need 2 pieces of paper. Okay, if there's no questions, we may end our class today. Just remember to sign in. Alright, I'll see you all next week and also in our practical classes. Thank you everyone. Bye bye.
Sir, next week this time midterm 是这堂课 midterm 就堂课。